So hello everybody and welcome to another video. Today we want to do things a bit different. We don't really have a presentation like in the other videos today. This is more a bit about the environment, about how to work as a data scientist, how to have your environment going, and what I want to show you basically what we're talking today about is there are these Jupyter notebooks. You probably heard about them. There is also the Jupyter Lab and the Jupyter servers, and there is Google Colab, for instance. We have this kind of cell-like environment. And basically, I want you to show you that you don't need that, and that you can just use Emacs for that, and how you can work with Emacs with an environment which is called the Org-Babel environment, which does basically the same thing, which is a bit more lean, which doesn't need all these kinds of stuff installed that you need with the Jupyter server. So let's quickly show us what we're talking about. So let's just fire up. I already touched this. So basically, here, if you have the Jupyter Notebook server installed on your machine, you can just type Jupyter Notebook, or you go to Google Colab or something like this, and you have kind of the same environment. So if I do this and I fire this up here, then I have my local Jupyter Notebook here, and it already starts Emacs, which is kind of a haunted thing, but it does this because kind of in my environment it believes that Emacs is my default web browser, which kind of it should be, but of course we have the Firefox. And if I go here to localhost, I have my Jupyter Notebook here. Basically, I could just have copy-pasted if it asks me for the key, but as I already just ran this, I didn't need this. So we have this Jupyter Notebook environment here, and I can open, for instance, a Jupyter Notebook a very primitive one here that I just have prepared, and we see basically what we can do here is I can type this in here and say, okay, I can evaluate the cell here, and then I get, okay, A equals 5, B equals sign A minus 1, and I get B, and then basically I can evaluate this, and I have C. And if I evaluate C, I get C out of this, so C is the B from this cell here. And if I change the cell here, for instance, I just want to have the sign of A, then my B has changed in background, and the kernel kind of has saved B. But if right now I evaluate C, C is still the same until I evaluate this cell, and I can kind of play around with this. And this is very convenient because it allows me to test out some, let's say, some Python functions and Python stories without writing whole Python files and then evaluating them as Python scripts, something like this without writing whole Py files. And it's also better than the Python interpreter, and of course it does, as you all know, images and things like that. It does a lot of things, and it gives us a lot of convenience, and this is what I see most data scientists working in right now. They just use these IPython notebooks to treat the data that they need and connect to their servers and all kinds of things, everything that is in there. So fine, so good. We said we want to go to Emacs and see if we can do something likewise. So let's leave this out here, and let's fire up Emacs. And we have our Emacs here, and this is basically called the org mode. So in order to get into org mode, I just create an org file, and I will call this my test Python org file here. Yeah, okay. The org mode, by default, if you open an org file, you see this here, it opens the org mode. If it should not open the org mode, you can just switch by hitting Alt-X, or Alt-X, basically MX called in Emacs language, and typing org mode, and then you're in org mode. So far so good, we are already in org mode, and we open the org file. And the first thing that we want to do is basically we want to go here and define some property So if you're interested in all that I'm showing you here, just search the web for Org-Babel. This is basically what this does. The org mode does a lot of things. Yeah, the org mode basically is comes from a mode, as it says by its name, to organize things. So it was just lists where you can kind of have your to-do lists in Emacs, and it kind of developed into all kinds of things. It also does spreadsheets and tables and things like that, all in Emacs, and all in this kind of org mode. Yeah, it's kind of a super mode in Emacs if you want to be like this. Yeah. So what I want to define here is I want to have a property, and I want to say header args, and I want to do this Python here. So as I said, I want to kind of emulate with this IPython notebook behavior. Yeah. And he will show you this is really cool, to be honest. So and what I want to do here is I want to run a session. What does it mean I run a session? Basically, otherwise all these code blocks that I have, so like these cells that we have in this typical Jupyter notebook, they would be executed separately in different kernels. But basically we want to have one kernel, and I call it here the PyKernel. And I want to have asynchronous execution. Yeah, so if I don't write asynchronous execution, basically it locks up Emacs until I run a new file. And what I want to show you basically is how you can use this. And right now this is the setup, and I want to have this setup basically evaluated. So in order to evaluate this setup, I type Ctrl+C, Ctrl+C. And when I type Ctrl+C, Ctrl+C, I get something up here, down here. Basically, my local setup has been refreshed. This is what I want to have. Yeah. And then, in order to open a source block here, you have to do some kind of configuration to get this convenient like this. I type just the shorthand here, this basically smaller sign SP, and then I hit the tab key, and I get something like this. Yeah. Very fast to create this cell. Otherwise, I would have to write this begin source Python and source in order to get my source block. But there is something called Org-Tempo. I will show you afterwards how to configure this. And with Org-Tempo, basically, you can have these shorthands in order to create these source blocks. Yeah. So far, so good. What did we have? What did we do in the other notebook? That's kind of pre-done for this video, but let's do this quick here. So from math, import sign, and let's say we have a equals 5 as we had over there, b equals sign of 5, and I want to see what b is, and let's evaluate this, and of course I get the result, and this is really fast. Perfect. Yeah. This is what we want. Yeah. And of course right now if I want to have another source block, sp tab c equals b plus 2. What is c? Let's print out c like this, and I get c. Yeah. Okay, this is basically what it's like. Yeah. This is the org mode, and you see this works kind of just like Jupyter notebooks. But there are some things that you need to be aware of. So first of all, you don't see basically here when the cell is evaluated or in this evaluated state. Yeah? So you saw basically there was something written, and then it changes and the result comes back because this is due to this asynchronous execution. But you don't see how this is executed. So one easy thing that you need to know is basically we have our kernel, and we can kind of directly access our kernel from here. Yeah, what does this mean? Yeah. So what I will do basically is I will open another window. I can do this with Ctrl X5 too. Then I get basically a second window here, and what we will do is I will make this window here one. And here in this window with Ctrl XP I can switch to different buffers, and one of these buffers is kind of the star PyKernel buffer, and this is kind of the Python shell or the Python REPL that I use here for all of this. And for instance here I of course have direct access to the variables that I'm using in my kernel. I can here also, of course, type commands and change things in the kernel, so basically the state of things. So let's see what the variable c is like right now. So I just type c and I have it. What is c squared if I want to know it, things like this, and I can of course use this just like as a typical Python REPL. If I evaluate something here, you will see I get this here, this blah blah blah, and this is basically what happens. And basically, if you want to know if something is evaluating, well, you just look at this and you will see the cursor down here somewhere without having these three signs here. So basically the sign that here you have a new command line, and it's kind of kept here while it's calculating. Yeah, this is kind of the way you see that things are evaluated ground if you want to know. Yeah, and this is of course handy because you can kind of interact with your notebook environment, if we can call it like this, with this Org-Babel mode directly in this way. Yeah. Something else that I want to show you is basically there you can play with the output, how things are output. So basically if I go here and I use my shorthand here, and I can say here, for instance, results, and then how my results are presented. Yeah. Let's leave these results out here. Let's just make D, and let's say D is I don't know, a list of A, B, and C, and then if I print D like this, you see what we have here. Basically, this is in this org mode. This is already a table, yeah, because it uses this kind of bars here, the pipe sign in Unix speak, if you want to. And this generates kind of an org table, yeah, if you want to, yeah. So as you see, the result is not presented as if I type, for instance, right now D in here, where I have my typical list result. So what you can do here is you can play with these results, and you can say, for instance, raw, and if I do this raw, then I get my raw result as expected from a typical Python interpreter. If I say results table, I get basically what we had before, and I can use this as an org table. Okay. Just make sure basically that if you have a lot of results, that you don't print them. Yeah? If you print a lot of results, the thing gets very sluggish. That's not what you want to do. But something else, of course, here, these results, they stand here. I can just remove this and get kind of basically can just remove this here. And as what I want to point out basically is, for instance, I can remove this, and if I do this here, it comes back. And all of this is just a text file. Yeah, there's no JSON thing going on like with these IPython notebooks and things like that. This is a standard text file. If you save this is text just as it's presented on the screen. And you can, of course, just write in here and make comments. And this is my Org-Babel file, and write your text and do things like outlining this and things like that. This is basically the way it works. Yeah. Nothing special here. Yeah. And you can make lists and things like this. And for instance, if I make here a star, it understands that this is kind of a list. So this is the first item and things like that. Just get basically into this Org-Babel mode. The second, yeah. And it has its kind of own syntax, but basically you can just write text and use this just as your IPython notebook, very easy, and open this anywhere because every text editor can edit it and it will look the same. Yeah, maybe without this fancy coloring, but it kind of looks the same, and it's just a standard text file. That's what I want to point out here. Yeah. So far so good for our results for this table and raw story that we have shown you. What to do if I want to print a file? If I want to print a graph, let's say it like this. Yeah. So very often as data scientists we have inline in our notebooks basically these I don't know, matplotlib outputs these plots basically. You can also do this here. I will just show you how to do this. It's a bit more fancy. There's a bit of work behind this, so I will use my shorthand. And what you want to do here is you want to use something which is called results file. Yeah? And I want to import matplotlib .pyplot as plot, of course, and I want to do my plot, and I want to make a dark plot because my Emacs has a dark background, and my screen here has also kind of a high resolution DPI, so I will just quickly change the DPI. This is all very standard. This is not important here to memorize, but I just want to show you how you can have a nice inline plot in this Org-Babel mode. Yeah? And I can use here, for instance, figure DPI, and I can say 210. Then I have a DPI for my figure of 210. I use this because I have here a very high DPI display. It's very small, but also a very high DPI. Okay, and I want to use as my Emacs is configured to have a dark background. If you use the standard Emacs, it's not dark, but then you don't do this. But I want to have a dark background, so I will use this block style dark background. In order to do my plot, and then I want to do my plot. And so far I have no data for the plot, and this is the typical workflow. So I want to plot XY things, and basically we do this just as in typical IPython notebook. I insert a cell above, and let's create our data. So what we want to do basically, what can we do? We can basically just make a quick sine graph, and let's import math for this. We imported math before, but only the sine function. Let's import the whole math because I probably need pi2 in order to do this. And let's create our x and y lists of points that we want to basically plot as down here. And I say for I in range, let's fill this up. Let's make 30 points. Let's make 50 points to make it a bit more. We have more points for our graph, and let's say math pi, and let's go to 2 pi. So times I divided by 30. This should work. Okay. yi, and we make here math sine xi and x append xi, y appends yi, and we have our list of points to plot. Yeah, so I evaluate this. Of course, result I get here none because I didn't put anything behind. So far so good. I have my plot here. If I plot this like this, it will not work. Yeah, so results file. I know in a typical IPython notebook environment, it would just put the file here, but this is not how things work here. Yeah, so basically you have to put this into a file and get the file back. So how do you do this here? So you have this save fig command, and this is just some hints on how you use all this. And basically you can do this for every plot that you use. Yeah, so most plotting use this at matplotlib and something like this. You just have to put it into a file, and then you say plot close, because otherwise, well, every time I evaluate this, I have like one image above the other image, and this is not what you want, so you want to close the plot and have the image basically shown. Now your plot is finished. And the next thing, of course, in order to display this, you have to output the file name, so you could just put the file name into a variable and then write the variable down here, but I will do this a bit like this, just here, so I just write the file name where I have this plot savefig. And if I do this right now, and if I evaluate this and hopefully everything works, then it says style is not available because it's dark background. Okay, so you see here, this is always very handy to have this kind of open, because you get here the error messages from your org table notebook. If you have your kernel open here somewhere, you see them. Otherwise, it's not like in these IPython notebooks where you get the error message basically below the cell. Here we have the error message here in this kernel that we have opened in our other window. So fine, so good. Right now I could say I did this in purpose, which of course I didn't. And right now I get basically this file here, and if I click on it, it kind of opens me a buffer, and because probably I did this just before, and I get this nice image of my assign function here. So far so good. This looks nice, but I don't want to have this in a different buffer. I want to have this in the same buffer. So in order to show this, you can use just mx, and you can do org, so alt x, in Emacs speak meta x, alt x, org display inline images, and you evaluate this, and if I evaluate this, I have my images inline, just as we used to it from the classic basically notebook. This stays a text file. It will not be displayed like this. I mean, I will have to run this org inline images in order to show the image all the time. That's basically how it works. So far so good. I guess this gives you a quick overview about how this works. In order to get this working like this, especially with the shorthand, you have to have some configuration in order to do this. So how do you configure Emacs? Normally with this .emacs file, which is automatically evaluated when you run Emacs. So I have my .emacs file. I don't have a lot of configuration in there, but some fancy things that you might want to have so that you have an environment like mine. All this up here basically is just basically my background, white background, what kind of font I use, things like this. This is just all show. This is all not very important. What's important for you guys basically when you use this is all this Org-Babel stuff. So Org-Babel, as I showed you, it doesn't only do one language, it does all kinds of languages, but you have to activate them. So I have here basically a list of languages that I want to use in Org-Babel mode. For what I've shown you, you should have at least the Python mode, just to show you that this works with multiple languages. Let's go back to our buffer. Where is it? And basically I could do multiple property lines here for the different kind of languages with header args and then the other languages, but basically just to show you, okay, let's do a shell story. So this then basically gets evaluated on the bash normally, and if I do here echo I'm great, well, let's do it. Let's not be so egoistic. Let's say we are great, because of course the audience is always greater than the presenter. And then we get this shell story out, and it evaluates the shell code somewhere in the background. Of course, this time not in the kernel because we didn't have a property for a shell kernel basically to have. But it would work in the same way, and you can just use kind of different interpreted languages. In order to allow to use them, we have to go to our .emacs file, and basically you have to do this Org-Babel to load languages. And basically you have here Org-Babel load languages, and you type this just as it's shown here, and you can of course remove the languages that you don't need. These are the languages that I use. So basically I use the C shell, then the shell, then Python, R, and Emacs Lisp in Org-Babel mode, likewise as shown here. What is very interesting is to have these shorthands that I've shown you with this, so that I can type basically like this. Let's open this file in a different window. Let's go back to our Org-Babel mode here. I guess it was called, what was our file called? Let's switch to our buffer. What buffers do we have open? Test Python, okay. So that I have this shorthand here. Likewise, so where I can type this little sign here and SP, and then I have my Python buffer. This is very nice to have. So basically, in order to do this, you have to add this here evaluate after load. So basically, when the org mode is loaded, you want to have something which is called org tempo. This is by default right now in Emacs, so it says require org tempo. And then basically you say add to list, and you want to have here, it's your shorthand. So basically this is SP for source Python, and I automatically get these source blocks for all these types of languages by typing, for instance, just likewise here, what I just did, if I type here SP and I do this, I get the source Python, and if I do SC, I get the source C block. That's basically how it works, and this is very convenient because you don't want to write hash plus begin source Python and things like this, that's the way it is. Otherwise, this of course uses standard Emacs bindings. What I do is basically other things, Org-Babel confirm evaluate, and the stuff is, if you don't set this variable basically every time you hit, in order to evaluate the cell block, what do? We type Control-C, Control-C, so if I want to evaluate this again, I'd hit Control-C, Control-C, and you saw it quickly, it evaluated here, The story is, we can do this, but if I don't set this variable, basically it will ask me every time, do you want to evaluate this code on your machine, which is quite annoying. So I tell you, of course this is kind of a security measure, but come on, you type your code, you know what's going on. Just set this variable to nil, you will have a much faster working environment. Org source preserve indentation. Normally if you don't have this, it indents this all a bit inside, and especially if you do Python code and have this indentation, it kind of gets messed up. So set this variable, it helps you a lot if you type Python code, so these are basically these two here, preserve indentation, and the second one, not to create some kind of indentation because there's an org source block. Python indent offset, this is basically a general one that in Python I use a indentation level of 4 spaces. It's not needed to set this, but this is kind of convenient for this kind of stuff. That's basically how you configure this. In order to work as fast and as convenient as I work with this, I use these org mode files right now for everything. They also work remote. Just to show you a remote session, let's try. So let's try to reopen a file over there. Yeah, right now it works. We have our files on the remote machine. Let's open on this remote machine test.org. And we have our remote org file basically. And right now, of course, everything I run, if I run this like this, it will run on the remote machine. So let's basically do something like the property story here. kernel, a good idea if you use this basically is to give it a remote name here, a different name than the one, so that this thing doesn't get confused. You also want to have it async, and if I do here, I don't know, import math, and let's say a equals 5, b equals sine 5, b, and I run this, it runs this as you have seen it on the remote machine. Yeah. Okay, it says, okay, you see here that sign is not found, but of course this is an error here. And if I execute this, probably I forgot to run this one here. Local setup has been refreshed. Now it sets up the remote kernel. You see it runs on the remote kernel. And basically this runs on the remote machine. And I could execute here, of course, remote stories basically just by opening this with SSH. So just to recap how you open something like this, you type SSH, your command name, and then you get a file browser, or you can just basically double point and put the file, but as you have seen, we had some problems with that. So basically we have this here, and if right now I go here into x52, control x52, and open my other window, and I have here then a buffer, where I have basically my remote story here, and this is basically my remote system here. Yeah, that's basically it. Yeah. If I type b here, I get b, and this Python kernel basically it runs on the remote system. Yeah. That's the whole story. What I wanted to show you about org mode, how you can use the org mode. I hope you have fun with this video. Sorry for the little hiccup. Maybe I will cut this out. Have a great time. See you. Bye bye.